This is Deception Island near Antarctica, and one feature you may notice about it is this nearly perfectly straight coastline on its east coast. And this coast is called Costa Recta. And of course, if you look at it, it's not perfectly straight. There are some bends, but it's crazy how straight it looks, especially if you zoom out. And to the north of it is this point called Macaroni Point, and to the south is this point called Bailey's Head. And so, what I immediately wondered when I saw this is, how did this nearly perfectly straight coastline form? Well, first, the way the entirety of Deception Island formed is from volcanic activity. This center lagoon here is a caldera, basically the bowl-like part of the volcano, and the actual island is just the top of the crater. And there's a lot more volcano that's under the water that you can just not see. But now, let's go over the question of this video. How did this nearly perfectly straight coastline form? Well, there have actually been many hypotheses about what formed this super straight coastline. And so the first hypothesis we're going to be looking at states that this straight coast was formed by glacial processes, and this was first investigated in this 2002 article titled Periglacial Processes and Landforms in the South Shetland Islands, Northern Arctic Peninsula region. And even though this doesn't mention Deception Island specifically, it lays out how the glaciers could have formed this cliff. So essentially, it is suggested that the glaciers that are on top of this region of Deception Island here slid down the coast, scraping the landscape and leaving behind something that was roughly this shape, and then the waves eroded the coastline even more into the shape we see today. And this hypothesis is supported by multiple things. First off, this ice cliff suggests past glacial activity, and also these deep streams suggest places that the glacier could have cut through. And the one thing that is agreed upon is that erosion by waves has definitely occurred along this beach, because many of the grains of this black beach are the same size, suggesting constant erosion from the waves. But that's the glacial hypothesis. Now, there are two more hypotheses that both involve fault lines. And if you didn't know, a fault is essentially a fracture in the Earth's crust that happens when two tectonic plates move away from each other or transform next to each other somehow. Now, most faults fall along tectonic plate boundaries, also called fault lines. However, there are some cases of faults forming on the inside of tectonic plates, and this is called an intraplate fault, and it happens in weak points on the tectonic plate. One example is down here in Missouri, in which a weak point in this tectonic plate has caused many earthquakes. So, since the majority of faults fall along tectonic plate boundaries, are there any tectonic plate boundaries around Deception Island? Well, yes there are. As you can see on this map, the place highlighted in red is the Antarctic plate, and over by where Deception Island is, there is this small plate called the Shetland plate. This small Shetland plate forms what is called the Bransfield Basin, and you can actually clearly see where the Shetland plate interacts with the other plates. And so, because of Deception Island's closeness to tectonic plates, two different fault hypotheses have come about. The first hypothesis is found in a study originally posted in 1996, titled Deception Island, Bransfield Strait, Antarctica, an example of how a volcanic caldera developed by extensional tectonics. And what this study suggests is that this coast was formed by a strike-slip fault. A strike-slip fault is a specific type of fault in which two sections are sliding past each other, similar to a transform plate boundary. So essentially, what it suggests is that along this fault, one part of the crust was moving north by northwest, while the other one was moving south by southeast. And that is how it created this super straight coast right here. The other fault hypothesis, first introduced in this article named Costa Recta Beach, Deception Island, West Antarctica, a retreated scarp of a submarine fault, published in 2005, suggests that this coast was not formed by a strike-slip fault, but a dip-slip fault. A dip-slip fault is when one part of the fault dips down and creates this pretty steep slope. And the main evidence that suggests a dip-slip fault instead of a strike-slip fault is the steep escarpment that is found past the beach. And so, as we can see on the street view imagery, more like trail view imagery, there is this steep cliff past the beach, which suggests a dip-slip fault instead of a strike-slip fault. But none of these hypotheses are confirmed for certain, and we may never know the true story on how this almost completely straight coast formed in Deception Island, but we certainly can marvel at it from satellite view. If you have any video suggestions, put them in the comments below, and I'll see you in the next video.